Welcome one and all, Coach J, section 11.1a. Hey, I hope you're having a fantastic day today. My apology for not being here in class today. My apology. It was one of those things there. But I will tell you this: we are going to continue in our lesson in section 11.1. Notice that over in the back table, back over here on this side, make sure that you get your note sheet as well as some M&Ms. You're going to need that for the activity that we're going to do. In fact, today, as we keep going through this activity, you're going to need 2 bags of M&Ms. Really, it's you and a partner that need 1 bag each, that you'll combine them together. And we'll go through our last chapter, real thorough chapter that we're going to hit on in chapter 11. I cannot believe it. We are heading towards being done. It's really exciting. All right. So with that being said, let's get underway. We're going to go through these sections, and you're going to need to make sure that you are ready to go, because there are going to be some times where you're going to need to understand that you need to stop the screen and go. Sorry, I want to make sure I share. Whoa, make sure I share. Let's see. Is this going to help me? Oh, there we are. Yes, I think that's it. Okay, so without further ado, here we go. There's a company that makes milk chocolate. You may have heard of them, called Mars. And they claim that the following distribution of 13% brown, 14% yellow, 20% orange, 16% green, 24% blue, and 13% red. Is this true? That is the question. Well, the idea of this is we're going to be heading into this chapter on chapter 11 called a chi-square test. Okay, that's what we're going to be looking into. That's kind of our symbol that's there. The thing that I want you to do real quick before we get started is I'd like for you to first take 2 bags. You and a partner will have 1 bag each. And in those small bags, I want you to total the amount of M&Ms. And then I also want you to tell me what proportion of them, or how many of them total, would be brown, yellow, orange, green, blue, and red. Okay? So you go right ahead. Ready? Go. Pause the video and do that right now. Go. Okay, you're back now, and hopefully in the total number of M&Ms, I'm just going to say for an easy answer that we've got 50, and you're going to total each of them. But I'm going to just kind of focus in on the brown section to say that 10 out of 50 were brown, okay? Now, as a class, we need to write down this hypothesis. Even though we're doing this individually, we're going to write down our hypothesis for our significance test, okay? The null test is going to be that we have to assume that the claim on the distribution is true, meaning what they say about each of the colors and their percentage, we're going to claim that is true. The alternative is to say the claim of the distribution or on the distribution is not true, okay? So there's a true, which is the null, and then there's the alternative, which is the not true option, okay? Now, here's what we've got to show. Let's suppose that M&M's claim distribution is correct. If they are correct, how many of each color would we expect to get in our sample? Well, in my context, I got N equals 50, okay? Yours is going to be a little bit different, but the N equals 50 is what I bring down here. So when I look at brown, once I multiply this together, what are we doing? We're multiplying N times P. So within this, we're saying that N would be 50. 50 multiplied by 0.13 would be, 0.13 times 50 would be 6.5, okay? So I would expect 6.5 brown M&Ms, and so on and so forth, okay? So this would be the expected value, where this up here is called my observed value. That's very, very, very important, okay? All right, so let's go to the next part here where we actually take our observed and our expected. So we observed that we in ours got 10. Wow, that's big time. Whoa, big time. All right, let's back up, back. There we are. Okay, so we got 10 here for the observed, while the expected would be 6.5. Well, to head towards what we call our chi-square here, we're going to take the observed minus the expected, 10 minus 6.5 to get 3.5. And once I do that, I'm going to square that 3.5 value. So I'm going to say, okay, 3.5 times 3.5. You get 12.25, okay? There we are. And once I do that, I'm then going to divide this 12.25 by my expected. So divided by 6.5. You get 1.885, okay? So what I'm going to do is I'm going to do that for each of these. What's my yellow? What's my orange, green, blue, and red? Because really what we're doing is we're saying that when we square it and then we divide it by its expected again, that's the distance away from what we would expect it to be from. And we're going to take all of those values down. Now, as we add up all the numbers in this column, this is our test statistic, okay? This is the statistic that we just calculated. So all of these calculated together would be put into here. And really the formula for this is our chi-square. And we say that it's the sum of my observed minus my expected squared divided by my expected. And that right there would be my, right there, that would be what my chi-square would be here, okay? Now, here's the question. What value within my test statistic would we get if our sample was very close to what was expected? Well, if our observed matched up to our expected, that means we would have a very low number in through here, which even squared would be close to 0. So anytime that we have a number close to 0, 0, for our chi-squared, we say that in that instance, number close to 0 for chi-squared, if our sample, sorry, I was just looking for this at the end. If our sample was close to what was expected, okay? Now, if it wasn't, let's say if it wasn't, it was much further away from what was expected, what value would we get for this test statistic? Now, this is not a very, this isn't a great answer for this, but we would just say a large number, okay? And we're going to look at what that means a little bit later, but just understand at this point that when we get a very large number, that means it's much further away from our expected value. Our observed was further away from our expected. And that's how we would attack that there. Okay, perfect. Fill out this chart real quick. I'm going to take a breather, fill out this chart, and transition then to the back side. I'll give you just a second. Pause it, fill out the chart, continue. All right, now it's golden nugget time, y'all. Your favorite segment. Yes, and some of you said this isn't a nugget, a golden nugget. Well, sorry, that's all I have at my house. I only have golden tablets at my house. I don't have nuggets, so I'm sorry about that. But nonetheless, golden nugget, here we go, okay? Golden nuggets. Let's give a couple here that we need to kind of know. Number one, golden nugget number one, we've got to know this, that when we talk about our hypothesis and our expected, okay? Our expected value, okay? So for instance, we have a null, and within our null, we say the claim is true of whatever the claim is within the context of the problem. Just make sure you put in context within it, okay? The alternative will say that the claim is not true, okay? And again, you don't have to put in context twice, but just make sure you understand what that's referring to, okay? Also, just right above that, make sure that you understand that expected values are the same as saying that the probability for each category, so we're just going to say the PI. So what does this stand for? This means probability of each category. This was, for instance, with our Brown, right? The 0.15, that was what, or was it 0.13 that went in for this? That's what we're referring to. And then we multiply this by little n, which was our sample size, okay? And that's what this is how I would get my expected value here, okay? Just a highlight there. Okay, number 2. This is number 2 golden nugget. The chi-square test statistic, very important. All right, within this, remember that the chi-squared is equal to the sum of all observed minus expected squared divided by my expected. So it's the sum of all of each of those values that are there, okay? And then number 3, big picture, we've got to also remember the degrees of freedom and p-value. P-value, we're going to look at table C, okay? And we'll look at that later. And then our degrees of freedom are the amount of categories minus 1, okay? Categories minus 1. All right, so here's our golden nugget table. Make sure you consume this. Make sure you understand it. And again, we'll continue to apply it as we go forward. Look at this right here. I want you to pause this video with check your understanding. I want you to go as far as you possibly can with this, and then we'll go from there, okay? All right, now we're back, and what we would like to do here is just go through the different parts of the process within these hypotheses. So let's make the null. This is a 6-sided die, and we've got to say that the claim that it has a probability. So the claim concerning the die's face has each a probability of 1/6 is true. I think I could have reworded that, but the claim concerning the die space has each a probability of 1/6 is true. Could have reworded that, maybe made it not as wordy, but that's how we'll go. Okay. If it is the alternative, we say the die is unfair and the distribution and the claimed distribution is not true. Okay? Cool. All right, B says calculate the expected count for each of the possible outcomes, okay? So as we do this, if it's equal, we have 90 total. We should have 1/6 of each, so 1/6 of a total of 90 rolls would mean that each should, if I rolled it 90 times, I should expect that I have 15 each for each face, okay? All right. It says calculate now, C, calculate the value of the chi-square test statistic. So now I'm going to go step by step through this and say, okay, this is now 12 minus 15 divided by 15. Again, it's divided by my expected. I square that. I then add the next one, which would be same thing, except 28. Then I'll go 12, 13, 10, 15, and so on. I'll throw that last one down. So the last one was actually 15. And I square it. When I find this, when I do all of this, I should get 14.4, which is my chi-square, okay? And the degrees of freedom, because I have 6 categories, my degrees of freedom should be n minus 1, which should be 6 minus 1, which is 5. Cool. All right, so hopefully you got that. The last one is a little weird because now we've got to use table C to find the p-value. And when we go to table C, we use our degrees of freedom. And once we see what our chi-square is, we find that the p-value is between 0.01 and 0.02, which just means that now we can say that there is convincing evidence. There is convincing evidence to reject the null. Okay? And we'll look at this a little bit later and then put a little context in there too, okay? We'll look at this a little bit later, but a lot of times when we look at a distribution, it's going to be much like lopsided or skewed. But we're going to look at that a little bit later. Hey, again, I hope this was helpful for you. Go back through. If you've got some extra time, start on 11.1 homework, or you could even go into section 11.2 or 11.1b. But other than that, continue to keep moving forward, and appreciate all y'all's help. Hey, have a phenomenal day, and we will see y'all on Monday. And if you got questions, email me, and we'll get after it. Oh yeah, by the way, test should be on the back table. If I finish these in time, I should be able to finish in time. Hopefully they're on the back table. Be blessed. Hey, care about y'all. AP Stats team out. See ya.